Algorithms. Today I want to go over the first free response question from the AP Physics C Mechanics Test 2025, the released version. There were at least 4 different versions that I heard about. And so here's question number 1. We've got 2 blocks and they're moving towards each other, different masses, different velocities. And so we're asked initially to make a chart with showing the velocities, the momentum, the initial momentum, and then the final momentum. The 2 blocks, they stick together. And so here's the initial momentum of block 1, and then just the m, the one that's 1m. So it's 2 v naught m, and then the 6m block. This is the initial momentum of that one. So -6. And so this one goes here. This one's already done for you, right? So they give you the chart. I just drew my own thing here. You're filling in. So the total initial momentum is -4 mv naught. That means that also has to be the total final momentum. So -4 mv naught. So here's the total initial momentum, and here's the total final momentum. That's what they ask you to do here. So it's just -4, right? And so they set the scale here because you've got 2 mv naught, and so it goes 2 spaces. Each space is just mv naught. So -4 mv naught. So we're going in the negative direction, 4 mv naught. The next thing they ask you to do is to come up with an expression for the maximum force. And they give you this expression that F max is sine A times T. And so in order to find and you have to start with some initial thing. So, some accepted convention, known formula from physics. So we know that delta P is equal to J. So delta P is so the change of momentum is equal to the impulse, and right. And so F is also equal to dP dt. So starting from there, so that means that delta P, right? So this delta P equals, and then the integral of f dt. And we have a function for f, so we're able to put that in there, going from 0 to the indicated time. Okay, but we also want to know what is delta P. So we want to have something to set this equal to once we solve it. So delta P. All right, so the delta P this is of the 6m block, so delta P 6. So it's 6m VF minus -6m V naught. Okay, well, here's the problem. I need to know what VF is, right? I need to find this final velocity, so I can put everything in terms of V naught. Okay, so -4m V naught equals 7m VF. So this is the total final momentum, right? Both blocks together gives us 7m, right? 1m and 6m, and then times VF. So VF equals -4/7 V naught. So I plug that in, and that's what I get here. -4/7 V naught. I combine all this together, and I get 18/7 mv naught. This now is delta P. So I have 2 expressions for delta P. One, integral f dt, and the other one, 18/7 mv naught. So that goes in here. It goes in here. I do the integral here. I get -fm over a cosine at from 0 to tc. So then putting in my limits, I get -fm over a cosine atc minus cosine of 0. But cosine of 0 is just 1. So I'm going to flip these and get rid of the negative sign. So this becomes -18/7 mv naught equals fm over a, and then 1 minus cosine atc. Solving for fm, this is what I get. So now this is in terms of mv naught a and tc, and everything is good. The next question, so they give you a different situation now. So instead of the first block having some other velocity, it starts off with mv1, or it starts off with v1. So we want to come up with an expression for v1 if together they end with the speed of v naught. They're still sticking together. So the principle that we're going to operate from is conservation of momentum, that the total initial momentum is equal to the total final momentum, right? This is the Greek letter sigma. It means the sum of. That's how I've gotten used to writing that. You could write like pi net, the net momentum. All right, and so so we have mv1 plus -6 mv naught. Forget the negatives, right? The negatives get a little bit tricky. And then 7 mv naught. I'm not going to try the negative just yet. I'll just leave it here for now. And so now I'm solving for v1, trying to get V1 in terms of V naught. When we solve for V1, we end up with V1 equals 13 V naught. Okay, now what if, so this makes sense. So V1, so they end up, um, uh, yeah, so, but anyway, if we make V naught negative, just watch, if we make V naught negative and we plug this in, what happens, so this would be 6 MV naught and then, or, minus, so this would be 1. So V naught, or this would be -1, right? V naught, negative V naught would be V1, which would mean that the 6M block and the 1M block were both moving V naught. There would never be a collision. They would never actually hit each other, right? But we know that block 1 is moving right initially, and so this can't be the possibility. So we know it's moving to the right, and so here's our expression: V1 equals 13 V naught. So that's the first question. I'm going to make others, and then I'll put them all together in a single video. So stay tuned for that. Thanks for watching. Don't forget to like and subscribe and share.